Now, we meet once more. Now, in our last video lesson, we did the direct online, starter, forward, and the reverse. Now, there is another final circuit I want us to do today, which is known as an inching circuit. This whereby, when you want the motor to run, you simply press a button, it runs, and then when you release the button, it stops. The only major change between this one, the inching circuit, and the DOL continuous running is the hold-on circuit, which is usually connected in parallel with our start button. So the circuit is more or less similar to the other one. We have got our isolator, the main fuses, the main contactor contacts, our thermal overload. I think had explained why we need the thermal overload, which has got some inherent time delay, and then motor terminals, again for a cage rotor, and you have got our star points. Now, this circuit virtually remains the same as the other one we had for the direct online continuous running. The difference is in the control circuit. Now, this one here referred to as the control circuit. And this one here we said is our power circuit. Now, in the control circuit, we have got the fuse, then the overload. There's a normally closed contact, which is used in the control circuit. And then we have got the normally open, which is connected when the motor trips, and then you get your tripping indicator. And then through the stop button, start button, and then our contactor coil, and then back to normal. So this contactor here operates on 240 volts. That's why we're going back to the N. Remember I said, in case you have got a 415 contactor coil, then the return will come to either L2 or L3. So when you want to run the motor, you simply press your start button. When you press the start button, the power feed is available through the control fuse, overload normally closed, stop contact not pressed, start push button pressed, our contactor is energized, and then when it is energized, these main contactor contacts will make, and then power is available to our motor terminals, and your motor starts the running. Of course, you have to switch on the isolator for the power to run. And then this one, the start button, we said is spring loaded. The minute you release it, the contactor coil is de-energized and the power is cut off. And hence the name inching DOL starter. When you press is when the motor runs. When you release your push button is when it stops. And I think this one is a common examination question in the neck. Remember, the purpose of this subject is to make you understand the subject. And then in case you are given any conditions, then you can use the knowledge to provide the circuit as required. And I think with that finishes the direct online starters. These are the motors which can be connected directly onto our power line. The size of the motor, usually the power supply will give an indication as to which motor can be connected direct online. Now, before we go on to the large motors, I would like us briefly to go through these accessories which we are using in the connection of our circuits. Now, these are the accessories we normally use for connection for our motor control circuits. And it's also advisable when we are doing electrical installation, you have a multimeter, and good practice, have one which is rated at 750 volts. Unfortunately, the one I'm having is rated a bit lower, but normally when you do electrical installation work, we need a multimeter which is rated maximum of 750 volts, which is available in the market. And then we have got the motor itself. You can zoom in. As you can see, there are three connections. One is labeled common, the other one is labeled V ohms milliamperes, and the other one is 10 amperes. Now the common is where we insert our common terminal, which is the black one, goes to the common, And then in our circuits, we're either measuring the voltage or continuity. We put it in the V ohms milliamperes circuit. Now, this multimeter here can measure volts, ohms, or milliamperes, and then it has got a provision here for 10 amperes. When you want to measure a current of about maximum 10 amperes, then you shift this one onto this place here. Now, this one's here. At the moment, we are going to use the meter to measure continuity of our accessories, so you know in case there's a problem, how to find the faulty one. So I'll be using the common and the volt ohm milliampere terminal. And then it has got an off position. It's good when you buy the meters, you buy one with an off position for saving of your cell in the battery. Sometimes you can forget it on. There are those other ones whereby you can leave it on and your battery can run down. Now the other ranges, for the volts, we have got the range on this side here. This one can measure volts DC, starting from 200 millivolts up to 500 millivolts. And then it has got AC. Now this one can measure maximum. Now the figure here of 200, when you are measuring a voltage less than 200, you set your knob to that position there. Or if you are measuring the 240 we are using, you can set it to the 500, the V for the AC. Remember, as I said, you need to get one which is rated 750 volts. And then you've got continuity, where there is the symbol of the diode in case you want to measure continuity of a circuit. And then we have got the current, the milliamperes, starting from 2000 microamperes up to 200 milliamperes. And then when you want to measure the 10 amperes, you set that one to the 10, and then you shift this one to that position there. Now when you want to measure ohms, this one goes back to that terminal there, and the ohms range is starting from here, which is 200 up to 200 mega ohms. So this one is usually, you have a rough idea of what the value of the resistance you are measuring in, and you set this one up to the higher limit. In case you don't know, it's good you always start with the higher side, maybe the 200, and then depending on the figures you get here, you can scale down to the value that is acceptable. You have got a hold on position. The reading you get, you can hold on, and in case it's night, you can also light the screen for you to be able to see. I think that finishes that one. Now let's move on to the accessories. Now for our accessories, when you do our circuits, we shall be running a practical circuits. I'll connect a practical circuits for you to view. We'll be needing an isolator. Now this one can be used in the lab when we are doing our experiments. In industry, there are other types of isolators. Now this one isolates all the circuit conductors, that is the three phases as well as the neutral, and it has got some overload. Again, thermoelectric. And as you know, isolators, normally the on position is up and the off position is down. Now these ones, again, they are available in the market. You can get them anywhere. And of course, the size, they give you the rating of the current you can handle. That will be determined by the motor that you want to switch or the circuit that you want to switch on to get onto your, for your isolator to feed your circuit. Now this one, it can be mounted, it's usually mounted on the rail. The rail, you normally fix it either on the wall or on the board where you want to mount it. And then this one goes on top. It's clicked like that. There is a mechanism here for clicking it on. There's some pushing mechanism here. You can use a screwdriver to push it on. But if you're an expert, you know how to click it on. And then you can either remove by sliding it out or pulling this one here and removing it. So that is our isolator. Now, in our control circuits, we're having a fuse here. Now that isolator, this one we're having here, it will serve the purpose of this isolator here and our main fuse. Main fuse is here. It's combined one. There is a circuit breaker. There is a overload mechanism inside which will take care of the fuses. And then for this circuit here, the control fuse, you can use a circuit breaker. Now the control circuits, the currents involved are very small, in the order of 1 ampere. But the circuit breaker we have in the market is one rated, I think at the moment is 6 amperes to go for our controlling circuits. This one will do the overload protection. And then, as we move down, we have got our, let's start with the stop push button. We have got our stop push button here. Now the stop push button is usually colored red, and it is a normally closed contact, the way it is drawn here. Now you can use your meter here. You can use the continuity range. You set the meter to the continuity range where the diode is shown, or you can even use the resistances to test whether it is okay. Now you usually resort to this one here in case you connect a circuit and doesn't work, but it's also good practice to test your components before you start using them. So in this case, I simply connect one end there and the other one here. And as you can see, I get the sound. Also from the meter, I get an indication of 0, 0. Now it's a stop push button. When you press the stop button, it should disconnect your circuit. And as you can see, the meter indicates an open loop. And then it's spring loaded. When you release it, it goes back to the closed position. So now we know our stop push button is okay. Then we have got our start push button, again, which is spring loaded. Usually written here, normally open. And it has got numbers 3 and 4. Now if you go back to the stop push button, most stop push button as a convention, they are always labeled 1 and 2 with an NC normally closed. So in this case here, our stop push button here, this will be number 1, that one will be 2. When we come to the start push button, normally open, it has got number 3 and 4. So we can have this one here as number 3 and 4. And then this one is normally open. So again, we can test it, again, using our continuity range. You push one terminal there, the other one there. The meter indicates open loop. And then when you press it, when you press it, this one is having some slight problem. When you press it, you get the noise, meaning it is continuous. So when you press your start button, it closes and your circuit is through. So you can simply test it by using a multimeter. Normally some of these components, when you buy them, they can be faulty. Now from the start, we have started with the start. The next component is the overload relay. Now the overload relay looks something like this. Thermal overload. It has got 3 terminals. Usually this one will come into the power circuit, and it engages, usually mounted on the contactor. Now this one here, when we are using it in the circuit, it will come and fit onto your contactor here. Now this one here usually has got a hook here, which engages with this notch here. So when you get to a contactor, it can only be inserted on one side. As you can see, this one here, there is no notch for this protrusion here. On the other side, there is notch here for this protrusion. Well, mine is broken, which engages with this one here, and then the pins go inside here. Then your feed will come through here, go through the contactor, and out through the other side. Written 2, 4, and 6. Now the overload has got various functions. Now one of it is you want to set the current at which it should trip depending on the setting of your motor. Now that setting is set. This blue knob here has got some readings. I don't know whether you can zoom in. It has got 8, 10, 14, and 12. And then there is this arrowhead here. So you set this one, depending on the current you want it to trip, you set it to that value. In this case, I've set it to 14. I've set it at 14. That means in case a current greater than the 14 amperes tries to go through, it will trip. But remember, this one has got a time lag. So the current exceeds the 14 amperes. After some time, it's when it will operate. And when it trips, this blue button here is the one that will jump out to disconnect our circuit. And then you can simply press and reset. Now we have got this red button here. Now this red one is connected into the circuitry. Well, I have not indicated here. It's connected in the circuitry such that you can also stop the circuit from this button here, apart from the stop button. This one also acts as a stop button. And then we have got some 4 terminals here. Now these terminals, one set is normally open, the other set is normally closed. Now the normally closed is 95, and 96. And the normally open is 97 and 98. So when it trips, the 97 and the 98 is the one which will close, and then you get your indication. I think those are the main features on your thermal overload. This one is a thermal overload relay. And those basically are the functions. The tripping mechanism for resetting, it has got a stop provision also. You set the current in which you want to trip, the value you want it to trip on, and then the connections for your circuitry. And then you have got the contactor. Now the contactor coil, I said there are various types available in the market. They can operate on 240 volts, and there are those which operate on 415 volts. I think we agreed on the connections, how you can do your connections. Now for the power circuits, when you are connecting your power circuit, it has got a terminal here known as A1, and another one here, A2. So the current flows through A1, through the coil A2, and back to the neutral. If it's 415, then we know it will go back to the either L2 or L3 through a fuse. And then, of course, they are labeled where the currents will come in. In the contactor contacts, we have got 1 and 2, we have got 3 and 4, we've got 5 and 6. So our thermal overload, this one here will go on the 2, 4, 6. And this one's here, you can see where the connections will continue. It's also labeled 2, 4, 6. Thermal overload here will also be labeled 2, 4, 2, 4, 6. And from there, it goes on to the motor terminals. And then the other component we have, now this one is also rail mounted, fixed on the rail. Normally, good practice, we have 2 rails, one for the power supply, then this one here will be on another rail here to be mounted, simply for safety purposes. Now the contactor coils also, you need to test them. And this one's here, you just test by the coil, in which case we go to the ohms range. Let's try 200, and then you simply connect A1 and A2. Now, most contactor contacts have got 3 terminals, A1, and then there are 2 sets of A2s. We can see that in one case, when we put in our thermal overload, we'll go in here. We may not be able to use the A2 on this side here, so another one is provided on this side here. So, to test whether your coil is okay, you simply connect your A1 and A2, and if it's okay, you should get an indication. In my case, I'm getting a reading of 411. So I can assume it is okay. So A1, A2, A2. So the A2s are connected together. They are simply to facilitate the connection of your circuit in case you have added in the thermal overload. I think that's all about the contactor. The next accessory is auxiliary contacts. Now, at times, we may need more than 4 contacts. Now, the common contactors available in the market, they usually have 4 terminals. And these 4 terminals, in this case here, all are closed. Sorry, they are normally open. Now, there is another version with 6 contacts, whereby 5 are normally open and 1 is normally closed. Now, these are the ones I've come across in the market. Now, in some circuits, we are going to see that in some other circuit, like when you do the star and delta, we may be needing more than the 4 contacts. Now, in that case, we go for what we call auxiliary contacts. And these are contacts which fit on top of your contactor. Now, this one here has got some 4 terminals, and they are all numbered. NO, normally open, normally closed, and normally open. So this one, contactor with the 4 terminals, auxiliary, 4 terminals. So we've got 2 normally open and 2 normally closed. Now that is the 4 terminal. You can also buy a 2 terminal auxiliary. That one will be something like this one here, which has got only 2 terminals. Which has got only 2 sets of terminals. And in this case here, the 2 terminals, one will be normally open and one will be normally closed. So depending on your need, you buy the ones you need. Of course, it's economical. You buy the 4 in case you need to use 2, then the other 2 remain as a reserve. Now, this contactor here mechanically latches with your contactor. So when you are buying this one, you must know the type of your contactor. If I get another make of contactor, this auxiliary contact may not fit. So when you are buying your auxiliary contacts, make sure you know the name of the type of your contactor, and then you can get your auxiliary. And this auxiliary fits on top of your contact like that. You simply slide it in like that. And then the contacts here will move together with the contacts of your contactor here. The ones which are normally open, they are normally open. The ones which are normally closed will be closed. Now in this ones here, maybe you can check the ones which are normally closed. Written NC, I hope it's visible. Now NC should be able to get us a reading. It's giving us a reading of 00 when my ohmmeter is set at 2000. Or you can also set, since it's a contact with no resistance, if you set it at the continuity, that one there, you get that reading to ensure it is normally closed. And then you have also got the other one normally closed. That one there. Now the first one is normally open. If I put that one there, is an open circuit. And this other one here, when I put it there, it indicates an open circuit. Now later on, of course, when we do a small practical, I'll show that when this one is energized, these contacts will also move in tandem with these ones here. The mechanism down here latches with this one here. When this one is energized, it moves downwards here, and the mechanism inside here also moves downwards. Now when we are removing it, at the back side, there is this protrusion here. You simply lift this one up and it slides, then you slide this one, you slide this one out. Well, it's a question of mixing old wine and new wine. This is a new one. But it should slide easily. You simply slide it in, and then it locks. And this mechanism here, when you want to remove it, you simply push it up, push it up, and then this one should slide out easily. Of course, some students, sometimes they just plug it out or push it out and then you damage it. Now, later on, we shall be doing our star-delta connection, whereby we'll be needing a timer. Now, this one is a type of a timer, and this one is mechanically actuated. Now, mechanical actuated, when you want to actuate it, you mount it on top of the contactor, one of the contactors in your circuit. And it simply slides like the auxiliary contact. It simply slides in like that. It has also got a protrusion here, again for ease of removing. And when it slides in, through this mechanism here, latches with this blue mechanism here, so that when this one goes down, when it's energized, this one will also be pulled down to actuate the mechanism inside here. Later on, we shall test and confirm whether that one is the case. So this one's here, when you push it in like that, it has got some two contacts. One, again, normally open. Normally open circuit, and the other one is normally closed. We get that indication. We shall see how we use the normally open, normally closed circuits in the circuit. Now, when this one is actuated, it starts your timing. Now, at the top here, you have got the timing which you can set. Now, there is the center mark here, which is where you set your timing. Now, this particular timer can go up to 30 seconds. And you simply align the number you want. If I want, for example, 10 seconds, I align them there. So when this one is actuated, this contactor picks up. After 10 seconds, it will switch from the normally closed and move on to the normally open will make. The normally closed will open up. We shall see the functions of those when we do the star-delta connection. Simply set your time. When it starts mechanically actuated, when this one operates, this one starts the timing. At the end of the timing, the contacts switch over. Again, it's kind of an auxiliary timer. Now, we do have other types of timers, and those timers can be operated on 240 volts. Of course, if you understand the circuit here, it should not pose a problem how to connect your timers in the circuit. That means a timer will be having a 240 coil or 415 coil. Then when it's energized, the timing starts, and then at the end of the timing, it will do the rightful bit, switching off and switching on. So you have got this one mechanically operated, and that other type known as standalone type, which is operated by the AC. Simply the choice is yours. Personally, I do prefer this one here. It brings less wiring. You simply plug it in and off you go. And I think briefly, those are the accessories we normally use in connection of our motor connection circuits. Now I think here I've fed all the contacts in the accessories. They are all there. But of course, the numbering, you don't need to memorize it. Different contactors may have different numbering. The idea is to understand the principle. Then any components you get, you should be able to think and connect your circuit. So this one is an inching circuit. Now, as you are when you design, sometimes you may need to pull these numbers for your technicians when they are to connect the circuit. And usually, normally, when technicians are being told these circuits here, they usually memorize these numbers here. When you talk about the overload, they know the numbers. But when you are designing, those numbers should not stick into your head. Any type you get, you should be able to work out what should happen in your circuit. And with that, I think that I finish all the circuits on direct online motor connections circuits. So for our next topic, we shall go for starting off the large motors. And then in one of those circuits, this is whereby I'll organize a practical for you to have a look, the connection of the components and how they operate. And of course, that will be the star delta. So briefly, go through your notes, through the books, I gave you references. Read something about large motor connections, how you connect them with your power supplies. They cannot be connected direct online. There are various methods. The one we'll deal largely with will be the star delta connection. I think with that, until we meet next lesson. Here we have got the components more or less put together for you to have a look at. We have got our isolator here. We have got the circuit breaker, then the main contactor, and the thermal overload already now engaged the way it should be when you connect it into the circuit. Then you have got our start push button. It's always green in color. Then we have got the stop push button, red. We have got an auxiliary contactor, 2 terminals. And you have got the other auxiliary contactor, 4 terminals. And we have got our mechanically latched timer. I think those are the components I went over through today and will be using in other circuits. The circuits may be using more than one contactor and maybe more than one stop push button. And of course, we have got our meter for checking various things. Key thing to remember, my meter is up to 500 volts. When you're buying one, buy one which goes up to 750 volts. This is the one which will be ideal for the electrical work 3-phase. But this one will suffice for us since many dealing with 240 volts. And of course, the rail where these ones are mounted, this one's available in the market. You can simply fix it with wood screws, 1/2 inch, big head, fix it on. And I said we have 2. This one goes to another rail. This one's on one rail. And then you connect your circuitry. We'll give a demonstration when we do the star delta of how the whole thing can be connected for you guys. the timer. Again, they're available. This one from 0.1 up to 30 seconds. When you do the star delta circuits, the manufacturer will normally indicate this motor should be running so many seconds in delta before you connect to the delta. So many seconds in star before you change over to the delta. And this is the timer whereby you set it. So in a big motor you buy, you should have a label indicating the time to run in star before you change over to the delta, and that's the timing you set it onto these ones here. Well, we'll talk more about it when we do the actual star delta circuitry. Touch.